Hello. I'm here today to talk about how CosmWasm is enabling interchain DeFi. We're talking a lot about interchain. Everyone's talking DeFi usually. And so we've been working on this for a number of years, and I want to introduce you how we can use our stack to do that. So first of all, who am I? My name is Ethan Frey. I'm probably known as the father of CosmWasm. CosmWasm I'll get into later. I worked at Cosmos since January 2017, building out IBC protocols back then, working on the proof of stake algorithms, and designing the SDK. I've then worked on many other things in Cosmos space, and in the last 3 years, have focused on building another smart contracting platform, a Cosmos native platform called CosmWasm. So this is an IBC first, interchain first smart contracting platform. I'm going to get into that. So I assume you guys know what Cosmos is. For those who don't, it was a pioneer in many ways. Maybe it's not the biggest one now, but it came back in 2016 white paper, 2017 building. It pioneered BFT proof of stake to prove that proof of stake could actually be secure. It pioneered building the app chain thesis along with Polkadot, and it pioneered this IBC layer, inter-blockchain communication. So it's currently got 50 blockchains on Cosmos, and by Cosmos is not just this platform, but it's really interconnections. So if you look at the bottom on mapofzones.com, I recommend you, if you have internet here, it's pretty crap right now, but if you do have internet here, check out mapofzones.com. You'll see 40, 50 different blockchains all connected with IBC. IBC is trustless bridges. They talk about scalability, security, and latency trade-offs. These resolve in 30 seconds with full blockchain security. Full security, signed by the validator set of the other chain. So it's basically allowing you to have security that any message that goes from one chain to another has been signed by the validator set of the other chain. So you can't really get higher security. It relies, if you compromise, you have to compromise one of the two chains to compromise the messages. So it's about the highest security you can get. They usually go with about 30 seconds to get a message across. And it's running pretty cheap. It's a stack that's available for free in the Cosmos SDK, and hopefully extending to new ecosystems in the future. So this has been a primitive. It builds a really secure state layer, proof layer, an interesting level of a very extensible transport layer for allowing multiple connections and channels between chains. And at the end of it, allows you to write application-specific logic on top of it. And that's what I'm looking at. So given this really fast, efficient, secure, extensible transport layer between 50 blockchains, how do you build applications on top of that? So that's what we're working on. I know Axelar is building a great layer 2 as well, connecting to Ethereum and other chains. And this is really Cosmos native. I forgot a slide what CosmWasm is, because I thought everyone knew, but CosmWasm, it's, I would say now, the second biggest smart contracting platform after EVM. It's on more than 20 blockchains. It's a WASM-based smart contracting platform, along with standard smart contracts, a large ecosystem of developers. It's available in over 20 Cosmos-based chains. It's released now on one Polkadot chain, on Composable. It's a Polkadot parachain. So we're actually 2 ecosystems now, and people looking to extend it to more ecosystems. And yeah, so over 20 chains in multiple ecosystems based in Rust. And I think that's outside the EVM, probably the most widespread decentralized smart contracting platform out there. Everyone else is really around 1 or 2 chains. So maybe there's some of the Hyperledger Corda stuff but outside of permissioned enterprise zone is, I think, after EVM, the second most. We're a very small second. EVM is here. We're down here. But you know, it's not Solana. It's not just Near. It's not just this one chain thesis. And so we built it from the ground up around Cosmos, around IBC, and architecting. I want to explain how we can help. So first, multi-chain. What do these words mean? So multi-chain, cross-chain, interchain. I want to kind of define how I see these words. So multi-chain for me, a lot of people talk about the multi-chain thesis. And they're often talking about, hey, look, we deploy Uniswap on Ethereum, on Polygon, on BSC. We deploy it on multiple chains. And it's the same code deployed in multiple places, right? They're not actually connected. Maybe the same company deployed them all. They're the same interface, the same utility, but really, like, you have one work with native local assets and one work with native assets, right? It's just showing this compatibility. I deployed it here, here, and here. There's no composability between them, right? It's easy. You don't need a bridge, but there's no composability. So that's simple. Cross-chain, that's a step up. And cross-chain is when you're actually composing by sending messages over there, but not really connecting contract to contract, but more like sending tokens. This is when you take, basically I'd say Ethereum and send it to another blockchain. Or USDC is wrapped through Axelar, sent to Osmosis to trade. Or you're using Wormhole to send messages over from whatever, Solana over to Terra or to BSC. These kind of messages cross-chain. They allow transferring funds, and by doing that, by moving tokens, by moving NFTs, by tokens between chains, you allow some sort of composability, right? Like I can take my Ethereum here, I can put in a compound, take my CETH here, then move the CETH to another chain, use that as collateral lending protocol, right? And because these tokens represent lots of different things, by moving tokens between chains, you're allowing composability between protocols, the first level of composability. And I think right now, this is available. At least we have a whole series of bridges, and all the Ethereum level bridges have been focusing on this, pretty much, right? I put Axel up there, but all these other bridges are really focused on moving cross-chain composability. So for me, there's something else, which is Interchain. And Interchain goes beyond that, right? And I think there's a great keynote speech we had here earlier about really, we're not worrying about which blockchain you are. Now, if I have to mint something on one chain, move it to another chain, and interact with the protocol there, I need other token for gas, right? I can't just interact with one chain. I'm using multiple backends. So Interchain for me is allowing basically contract-to-contract composability. That is where my lending protocol will immediately liquidate assets on a DEX on a different chain, right? So I'm coming from Cosmos, right? So if you build a lending protocol for Yumi, for example, and they liquidate their assets by trading on Osmosis, which is the biggest DEX, but they're different chains. And that's for me Interchain. They actually compose it. Maybe they're holding LP positions. You have this Quasar, which is launching vaults, which actually are contracts holding LP positions on other chains and investing on other chains. So these contracts on one chain interact with contracts on other chains. And there's a whole other level of difficulty. So you can't just say, okay, we're moving tokens, because the way you compose tokens is you send them, if they fail, you send them back, right? It's a pretty simple process. So once we get here, it requires much more thinking about how you compose these aspects, and also a much more secure, long-lasting bridge, right? So if I move a token, I can roll it back. But let's say I have a staking derivative trashed over one that goes to another one as collateral lending protocol over here that's being used then borrow something and stick that over in an LP pool, and I want to unroll that. Okay, I've staked that. I have to maybe wait weeks to unstake bond this, pull it back, pull it back, pull it back. It's very hard to unroll these things. So once you've gotten that much, you can't just do something like Ren BTC and say, hey, everyone, you have 1 month to pull your collateral off the bridge, because its collateral now has been gone off 7 layers deep into different blockchains and actually staked in very complex ways. So once you have Interchain, you need a whole nother level of secure, long-lasting, and trustable bridges that you can use for extensible bridges to compose with. So I want to put this as a frontier. I think most people here are pretty open-minded. We understand cross-chain. We're working on this somehow. And this is great, right? And Interchain for me is maybe I only work with one chain and send messages on one chain. And under the hood, it's relaying, and I'm monitoring assets over 7 different chains that are composing across blockchains. So I see this is the future, and this is the Interchain future we're going to. They're not ever really, the end user and developer can abstract out a lot of that. But the developer has to do a lot of the work for this to happen. Now, once you get into this, so I said, I've been working on IBC design back since 2017. CosmWasm design first. We spent a lot of time working with the IBC implementations to make sure that we could, how the lifecycle works, how we can simplify it, what are the minimal hooks we need, what are these conditions, how do you design IBC contracts. Now for IBC, Interchain, they're different. Interchain is more broad than IBC, but IBC, I believe, as the most advanced developed Interchain protocol available today, if you're in Cosmos, right? Polkadot has their XVM, which I think is a little less, but just similar stuff. And many other chains are working to build this level of composability. So you don't have to go for Cosmos, but at least you can learn from it. I think Cosmos really, really is the thought leader in this space. on the app chain interchain thesis for many years. So I think there's a lot we can learn from it. Now, when you learn about it, we have to change our whole thinking, right? The way you think about transactions, when you compose, and I write one contract calls another contract, I assume a lot of things. I assume that if this one fails, right, I can say, okay, I'm going to transfer from of my CW20 asset to move it here and do this other, call this other swap, right? And if one of those fails, I can revert the whole transaction. They're synchronous, they're in one transaction. As soon as you get interchain, they're not synchronous. You have to care about that, right? You have to make something and say, this might fail. But if it fails, I have to be able to revert it manually. And that's a huge, huge change, right? You have to understand it. Like, I can't just say, okay, I am going to swap here and then swap over there and then revert it. So maybe I can't revert it. So you have to think how to manually revert this action, right? So if you want to have it, if someone starts doing something, you have to be able to manually revert it. You have to be able to receive this succeeded or failed. You have callbacks, right? Like, it's more like a promise methods, right? So I start a transaction, I change my local state some way and start a transaction on another chain. When it fails, I'll have to revert it back to the original state as if I did nothing. Or you see, I commit it, right? Especially when you're doing like LP positions or lending protocols and the exchange rate might have changed in the meantime, you need to lock it in. So that becomes a little more complex to think about. You really have to take that into consideration when you're designing these and what level you can actually do over chains. You can't necessarily guarantee it. The other part here, this rollback, is queries are not immediate. So one common thing I've seen for DEXs, for example, right? Like, I have a multi-hop router. I'm going to do swap A to B to C. So what you do, you can query, you can simulate call. So first I say, okay, I'm going to swap A to B, okay, B to C. I can do it. I can query and figure out how much I'd have at each step, and then execute it. I know, okay, I can pre-calculate it, I can do this, I can find out the conditions before I execute my messages, right? Or I can execute one swap, know how much I have to do the next one. When you're composing in this sense, you don't necessarily have access to the queries. Your query is not immediate. A query is a message you send to another chain and get back some minute later. So effectively, everything you've queried about another chain is old state. It's stale state, right? So you have to worry about that, and it's not the current state. So if you execute it, I query the chain, get information, execute it, it might be different. The price might have changed 5%. You don't know, maybe it's 0.1, you don't know. The price of the other LP, you cannot guarantee because my query says the rate is good, that the actual execution will have it either. So this idea of asynchronicity and actually designing a protocol to handle old state to get and gracefully roll back is a key component. I see a lot of people trying to do these automatic abstractions around it. I think it's nice, and for some things like token transfers and maybe a swap, you can abstract it out. You can assume this works, right? But a lot of techniques as you get to things like, okay, I want to do a pull back a swap in these conditions, right? And then I'm going to invest in this other LP, but if actually the swap doesn't work well, I don't want to split my stuff, right? Like, so these large, complex conditions, they're tricky to do, and you have to make sure that you have multiple steps in orchestrating the workflows, especially if you're triggering it here. I start with step A, then step B, then step C. I get callbacks that orchestrate it locally. So this is more and more complex, and one of the design things you need is, as you start doing this, you realize you need oracles that can be trustless to cache queries. And the last point, I think, which I came across often, is this one, the custom protocols, right? So if I try to do something that involves like swapping, investing LP, and doing some arbitrage opportunity, I query the state and see there's a great arbitrage chance here, but to execute it, I totally lose money on that chance because, you know, someone else took it. It's a minute old. My information's a minute old, 30 seconds old. The message takes time and front run. So I actually don't know there's a good chance. So I can't necessarily do this complex workflow of A, B, C. I actually need a different protocol. And maybe I need a contract on other chain to execute my logic. And I just say, hey, trigger this message here, trigger this complex logic over there synchronously, and either do that successfully and fail, and then come back to me as one success. So you actually think where the logic is. Do you have all the logic over here doing very primitive transactions to the other chain? Or do you move the most of the logic here and then trigger a high-level call which can execute synchronously? So there's this whole large design space. I just want to open it up, and so I'd love to talk about it, And I want to mention it's hard to hear here probably. I have a hard time hearing myself already. So I just want to really mention this space is huge. And I'll talk a little more, but I think it's too hard to really cover here. I just want to tease it now and get people thinking about these concepts. So I'm kind of introduction. I would love to, especially any developers, architects here, they're working on interchain applications. I'm happy to talk to you later. Come up to me later or find me around this next 2 days in the conference. Now, given that design series, I say CosmWasm IBC is nice. IBC provides extensible thing, and CosmWasm allows you to write that protocol level. We don't just worry about the token transfer. You can write custom protocols from A to B, right? And what this allows the IBC is not just I can do arbitrary cross-chain, but you send packets across the line. You can define your own logic. You can deploy 2 contracts in different chains and do it. A lot of IBC was done by custom Go. It was like native code. Like Cosmos native Go code. So you didn't upgrade your chain, you have new logic. If you want to do something else, you wait 3-4 months to deploy a new version in here. So you can give really well-defined primitives there, but you can't deploy new logic, new app-specific logic. You can't go quickly. You can't iterate. You can't test on production, I'd say, right? At some level, or at least in testnet, you start deploying 2 contracts to talk to each other and improve the protocol on the fly from real feedback. That's not possible with typical IBC because it's static. So CosmWasm allows dynamic IBC, which maybe is normal for Ethereum world, but really saying, hey, it's not just dynamic contracts, but the actual protocol between the blockchains is dynamic. Although we inherit the full security of the transport and state layer, message layer from IBC and light clients, the application level logic, the business logic can be very dynamic. What we do here in CosmWasm, if you define, right now, for over 1.5 years, we've had this out there, that you can define a CosmWasm contract and define a series of hooks. It's called IBC enabled. You define these hooks, and then it will immediately get a channel that can connect to other contracts. And the hooks allow you 2 things. The first thing is channel handshake. So when 2 contracts want to talk to each other, they make a channel between them. It's between a trusted channel between 2 blockchains. And that's version negotiation. You get like, I try to connect you, okay. Then I confirm it worked. And then we close it. So we have this basically a TCP/IP handshake going on here with application level hooks. You can imagine HTTP, the header, the sync, they're doing the auth login part of it, right? And once it's established a long-living connection, then you have these packets. Over 1 channel, it sends lots of packets. So the sender can send the packet, and after that, if you're guaranteed that if the other one sends it, you'll get a packet receive message eventually, and you send an ACK that will go back to the other one. This may never be called. If you never called this, you get a packet timeout eventually, right? So if I send a packet, eventually it will either go to a receiver on the other side and an ACK on my side, or the caller will get a timeout and the receiver got nothing. So we get one of the 2. It's guaranteed eventually you get one of those 2, exactly once. So you get this life cycle there, and with those hooks you can say, hey, look, I sent a packet, wait for a response. I got here, which might be an error, application level error, or an application level success with other data. Hey, maybe a timeout, it never got sent. That's also basically an error mode. I should take his error mode and roll back. So then it can handle rollbacks from it. So I'm given these entry points into my contract. So you're actually basically think like your smart contract gets these entry points to the lifecycle. In some level that's pretty low level, but we allow you to have your packets and start building this complex logic of, okay, send token, receive token, but you can build any logic you want as packets. So you can use protobuf or JSON or any of the format you want to, ABIs, to encode packets and then call it. And if you have 2 contracts on the side, you just import these Rust types between them and are sending these types across the wire and defining any sort of distributed protocol you want. You can imagine like gRPC or something like that, right? Or any sort of thing you want there. And you say, okay, I'm sending messages across the wire, and you really just a distributed system design at this point. You have full access to it. You're not limited just to moving tokens or contract calls. You have the full life cycle. You can simplify it and say, hey, if I'm just doing contract calls, someone makes one design that works for contract calls, and then you just use theirs, right? It's easy. But if you want to design your new one, this allows you to develop new ones. So yeah, we've currently allowed it. The hooks we have here, you see it, these engines, We allow version negotiation. So the channel handshake says, hey, am I talking the right version? Which features have you enabled? Maybe I'm doing a contract call and I want to see if I'm talking to a CosmWasm or Solidity side. I need to know information on the other side of what versions we are, what compatibility levels, what formats we expect, right? So we have this initialization logic hooks, and we can then return arbitrary acknowledgement. So we can, any sort of application level data you want to pass, you can pass through it. So we allow this, and really, so we can do both things, novel protocols and this one. So we've built contracts that speak standard ICS 20. ICS 20 is a Cosmos standard for moving tokens. So we have a contract that can send tokens back and forth, right? But then you can add a logic, what you do with it, which contract you allow, CB20 tokens, you can extend it a little more, right? Metadata. And then you say we do cross-contract calls, which is a standard in interchain accounts in Cosmos, and we can implement that as a contract as well. But then we say we want to build new ones. And so this is where it gets interesting. So Osmosis said we want a new protocol for allowing contract swaps, right? We don't want to build a complex thing, and they basically extended it. So what you do is you'll just take a packet saying, I'm sending these tokens over here. I want to swap them at the this minimum price on the side and get the tokens back, right? That's one primitive they want. And so they built a new protocol using CosmWasm. They hooked in there. And so you basically send a message there, it calls a contract on their side, do the swap. If the swap fails, it sends you back your original tokens. And if it succeeds, then it'll send you back the resulting tokens. And then you're guaranteed at that point to have a primitive they built on CosmWasm, this primitive that now says basically send token, swap, and get token back. And now that, on this level, they dug into it, right? They dug in to all these hooks. They use these hooks to build a higher level protocol that says atomic cross-chain swap. And that's pretty awesome. So now I can go another chain. It's not immediate, it's not synchronous, but I can say swap this rate or not, and I will get a call back when it's finished. I will know some blocks later, hey, here's your money, it worked, or hey, here's your money back, it failed, right? And then I can worry about that and build higher level protocols on top of that in my app logic. Another example is Wind. Wind is a project, I'm an architect for it. It's on Juno network, Wind DAO. You can check it out. It's Interchain DeFi on Cosmos. Right now, there's a distributed exchange and building staking derivatives. The idea of this is basically combining the DEX takes cross-chain. So we have other cross-chain tokens from other Cosmos chains over Axelar going onto the DEX. That's the first step. The second step is launching staking derivatives. So hey, you want to launch staking derivatives on multiple chains to control them locally. So the contracts will deploy on different chains directly, multi-chain, but we want to integrate them. So the way you integrate them is we have the one DAO on one chain that can use cross-chain governance, send messages across the chain to control the staking derivatives on other chains, set the validator sets cross-chain, and receive the revenue cross-chain, right? So, hey, we can deploy contract here, and our protocol is basically set validator set and collect revenue. And that's a very high-level thing rather than saying stake, move token. It doesn't have to do it. So you interacting with the staking derivative, you never leave your chain. You stay in your home chain, staking it, getting your rewards, anything else, and then it composes with these other staking derivatives. You can have a swap locally that compose with a DEX remotely. And so our DEX talks to our DEX, our staking derivatives talk to our staking derivatives, and a high level between them, and you as a user just see one part on your local chain, although it composes behind the scenes with novel protocols, basically talking to one of our contracts, talking to one of our contracts across chain to allow that. Yeah, it just launched the DEX a month ago. This is launching soon and doing outpost, LPing, stuff like this. I think it's going to be a lot of novel stuff. I'm very happy to architect it. I'm working here as an architect for it and helping bring some of these ideas into production, like into DeFi, because I've been pitching ideas for over a year, year and a half, and a lot of things don't go to production, so it's really fun to be able to architect this stuff out and see a team bring it to production. So I think it's going to be an interesting project what they build out there. Another is mesh security, which I'm very happy to work on. Mesh security is kind of mind-blowing, right? So this is Sunny from Osmosis. Probably heard of him. Great visionary. So I'm working with him. So I'm Confio team. I'm there working with them and Juno team, DAO people. Basically, this is like, for me, almost a pinnacle of the Cosmos. It takes proof of stake and interchain and combines them. allowing cross-chain proof-of-stake staking, multiple staking. That means if I'm staking on one chain, it's kind of I can use that weight to control another chain, partially control it. And I can opt in if I'm a small chain. I can say, okay, I want to borrow 30% of my my tokens from this chain and 20% from this other chain to give me security, and I'll give them my staking rewards, and they can do it. And so allowing the same collateral to be used over multiple chains at once, and giving guarantees over chains. So basically, we're not moving tokens over chains, we're giving promises of collateral, of slashing, of rewards. So the proof of stake is working. Basically, this chain is staking on this other chain, and this chain is enforcing invariance on that one. And that's kind of mind-blowing. You have to really watch Sunny's talk. I can't do justice for it. There's a great talk from Cosmoverse. If you look up Sunny, Cosmoverse, mesh security, this was September. You can see the vision. I think it's a very, very cool vision. But basically, you can have multiple blockchains borrowing some amount bidirectional. I'll borrow 20% of my security from you. You borrow 40% from me. And the delegators on blockchains can cross-stake. And that begins this web of trust. He likes it in NATO. I like it to more the EU, of kind of like one zone of joint security and joint commerce to really bring this to a level. And when you have that, if you have these cross-chain protocols, if I'm moving my swaps over here, my LPs over here, my lending protocol here, my token issuance here, my yield farming here, at that point, I have to trust that all these chains are secure, right? So if I build this complex application, the bridges have to be secure, but hey, if the DEX gets hacked, everything built on top of the DEX is broken too, right? So this way, you provide this mesh of security that we kind of guarantee some security levels from the chains that you're working with. We have economic relations between chains. We have cross-chain collaboration. We need to build the security relation between chains as well. I think this is just whetting your appetite, and this is being built as CosmWasm contracts, right? So this is like the future of proof of stake, joint over multiple chains, spread out in a whole network mesh of security. I think it's a pretty far cry idea. We knocked this out, me and Jake, in 2 days. A prototype, it worked. We had one cross-chain staking working. It's a very, very prototype proof of concept, but we could cross-chain stake with this. So I want to say the level of your imagination is a limit, right? So people look at moving tokens. We're like talking cross-chain governance, cross-chain LPing, cross-chain swapping, cross-chain proof of stake, collateral, yield farming, all this stuff can be built. And so I want to say, if you really want to experiment, even if you're an EVM and you love that stuff, I think it's very helpful to learn CosmWasm and try stuff out. Right now we have this ability to allow very, very complex stuff. And I see this, maybe it won't get huge business capital until it hits Ethereum and the EVM chains, where they're 100 times bigger. But I think a lot of these new ideas are coming out this year. There are a lot of new chains coming out this year that are really pushing new ideas forward. And I see 2023 really pushing the Interchain and the idea of the Interchain and the Cosmos to really go forward. So yeah, that was my brief idea into it. Like, what can be built with CosmWasm? What can be built in Interchain in general? And like some concepts in it. I'd love to follow up on it deeper. There's no way of going into all that complexity, but I just want to open your mind to complexity. So please jump in. There's a website. This is, I think, a really cool Discord channel. There's a lot of technical Discord discussions, especially if you want to learn CosmWasm. It's the best way. There are developers from over 20 chains, over like 50 projects jumping in there, helping each other out. So also core developers from our team. It's a very, very, very technical. I think it's one of the best technical Discords I've been on. There's no when moon there. There's no token questions. It's really technical questions, right? From beginners to super advanced level, and feedback on it. Yeah, follow us on Twitter. Here's some introductions on GitHub. This is our GitHub repo, and this is some of the highlights of it. But yeah, check it all out. And please meet us here. This is Misang. Can you stand up? Too. This is head of sales, business. Meet with her too. Me, we're around here today. Sarah in the back in the yellow jacket. So find any of us if you want to talk to us. And I'd love to talk about CosmWasm. And yeah, how, if you're interested in Cosmos, CosmWasm, IBC, smart contracting, I'd love to talk about this stuff. I'm giving a talk Saturday at 5 p.m. in East Denver about what Solidity Ethereum can learn from CosmWasm. We've learned a lot from Solidity, and like give some back in terms of like security and contract developing flows. But yeah, for interchain stuff too. I'd love to share ideas, and I'd love to learn here of projects people are building. So thank you very much.